Okay, good morning, guys. Let's quickly go over this. So for this first one, there's a lot going on. Just take it piece by piece. I always tell you guys, try to simplify on the inside if you can first. All right, is there anything there that simplifies? Okay, good. 3 and 12 can simplify. Good. So 1/4. I also see 2 x's on top. What can I do with those? Add their exponents. So let me actually write this on the side. This is going to be 1 over, if you add those exponents, it's going to be squared, x squared. You get a 4y to the 1/2 on the bottom. And then what could we do with z to the negative 3/4? Okay, you can move it on top. So this is going to be z to the positive 3/4. All right, we still have that negative exponent on the outside. What can we do to change that? What do you think?
Put 1 over on that. Like 1 over.
I don't like that much. Okay, it's, yeah, 1 over would work, but then you'd have to know to flip it. If it's already a fraction, you don't want to make it more complicated than it needs to be. So what you can do is just flip the entire thing. And this is going to get you 4y to the 1/2 over 1x squared z to the 3/4. That's what changes this negative 2 to a positive 2. Are we okay with that?
Can you get rid of the 1?
Yeah, sure. That's fine. Angelina?
Wait, why can't you just distribute?
Yeah, so good point, right? I'm doing one way. If you did it another way, that's fine. That doesn't mean you did it wrong. Just pay attention. Maybe we got the same answer. If we didn't, then maybe you made a mistake somewhere along the way. But this is what I chose to do, so it shouldn't be a big deal. From here, we can distribute this exponent of 2 to everything on top, and then everything on the bottom. So we get 4 squared, y to the 1/2 squared, over x squared squared, and then z to the 3/4 squared. All right, and then 4 squared, we should get 16. Y to the 1/2 squared, what does that get you? Just a regular y. And then what do we get on the bottom? X to what? X to the 4th. And then z to the, bless you, what does that become? Okay, 6/4, does that simplify?
Yes,
So 3 over 2, nice. There's nothing more I can do here. All of my exponents are positive. Everything is fully simplified, so then that would be your final answer. All right. Okay, so what about this one? What do we think we do here? All right, this was yesterday's lesson. Anyone remember? Alejandro.
We just like multiply on the that times square root of 5 plus the square root of 6.
Yeah, good. So if you notice you have radicals on the bottom, that is not simplified. So you need to multiply by the conjugate. So we're going to do square root of 5 plus the square root of 6. And we're going to do that on the top and on the bottom. All right. What was our shortcut for the bottom? What does that become? Okay, good. So we square the first. So square of 5, or square of the square root of 5 is 5. Minus, you square the second, is 5 minus 6. All right, and then what can we do on top? But what can we do on top? Any ideas? Okay, FOIL, right? So first times the first is going to be 3 square root of 5. Outer times the outer is going to be plus 3 square root of 6. Inner times the inner is going to be minus. These are 2 radicals, so we can multiply them, square root of 10. And then negative square root of 2 times positive square root of 6 is negative square root of 12. Are there any like terms on top? No, doesn't look like it. Unfortunately, that's how we have to leave it. I know it's not the prettiest thing in the world, but that's what we have to do. Can we do anything to the bottom? Good, right? So we can combine those like terms and make it -1. So after doing that, we should end up with no radicals on the bottom. All of the radicals can remain on top. All right? All right, I purposely picked these problems just because they are slightly on the challenging side. On your quiz tomorrow, they're not all going to be as tedious as these problems. You're going to have some pretty simple ones, but I will say for all of them, you do need to be careful, right? Little mistakes can add up, right? So you don't want to consistently be doing the same mistakes every time. So your quiz tomorrow will have 10 questions, all for your response. All for your response. We don't do a ton of multiple choice in this class. So you get 10 questions, all for your response. All right, so 30 minutes. So that's about 3 minutes per question. Some of them are going to be a little bit easier. Some of them might take a little bit more time, all right? So definitely pace yourself. It's might not be, like these individual lessons might not be extremely difficult. What's difficult is throwing all of it in a 10-question quiz and I just say simplify, right? And you have to remember, was this a rational exponent lesson? Was it a -1? You have to remember all your little rules and things like that. I might throw in a bunch of negatives and you have to know what a negative exponent does versus a negative just hanging out at front, that sort of thing. But I highlighted some questions to go over with you guys. I would hate to talk the whole time, so I want to give you guys a chance to work. So I'm going to try to quickly go over this. Let's start with 1. All right, anyone have any ideas? What can we do first here? Gabriel?
Distribute the exponents.
Sure, yeah, I like that. Let's distribute the exponents. So I'm going to take this 2 that's on the outside, and it's going to go to every single term. This -x you can treat as the base, or you can treat it like -1, right? If you think that's going to confuse you, you can treat it like -1 every single time. So I'm going to do that. This 2 is going to go to every single factor, same exact thing with this 2. And then writing it all out, we get -1 squared, x squared, y squared, and then z squared squared. For this one, we get times x squared, and then times y squared squared. It's a little laggy today. Sorry about that. All right. Are we good with that so far? That's just the first step. Are we okay with that? Anyone have any complaints about that? Okay, good. And then now we just simplify these as much as we can. -1 squared is just 1. X squared and y squared are already fully simplified. What's our rule for a power to a power? Just multiply the exponents. So this is z to the power of 4. Same thing with this x squared over here. What about this one? This is going to be y to what power? Nice, the 4th. All right. Are we done, or is there more to do? Simplify what? How? Good, right? So I see an x here and an x here, a y here and a y here. You can add those exponents. So this is 1x to the 4th, y to the 6th, z to the 4th. You don't need that 1 out front if you don't want it. Right? I'm assuming it's a 1 always. Any questions on that one? I think we're pretty okay. All right. I'll let you guys try number 2, but we're going to try number 3 right now. All right, this is the one that I see maybe the most mistakes on. What does this 2 mean we need to do? Are we going to distribute it to each term like this? No. You're going to have to, write it twice, FOIL it. Nice, guys. So this is going to be 3 minus 2 square root of 3. And then we get another 3 minus 2 square root of 3. All right. So I'm going to do first times first. What does that get you? 9. Outer times outer. What does that get you? Good. Minus 6 square root of 3. You can only do a radical times a radical, whole number times a whole number. Let's do inner times the inner now. What does that get you? Very good. And then let's do the last times the last. What does that get you? Okay, so we get -2 and -2. What does that get you? A +4, and then square root of 3, square root of 3. What does that get you? 3. So we get a 4 times 3, so what? 12, right? Plus 12. All right, and now we can combine like terms. What are our like terms here? Okay, we have these two -6 square root of 3's. What do those become? Good, -12 square root of 3. Again, you treat these like variables, right? Treat the square root of 3 as if it was a variable. If you did -6x minus 6x, that would get you -12x. So leave the radicals alone. You're just combining the numbers in front. What else can we combine here?
9 and 12.
Good, right? 9 and 12. So 9 plus 12 is going to get you 21. And then this would be your final answer. A note on the order, maybe you guys did the radicals first and you did -12 square root of 3 plus 21. That's fine. I don't really care what order they're in as long as the signs are consistent, right? Make sure that the radical is the one that's negative. All right, so be super careful with that one. Whoa, hang on. Okay, on this first one, let's throw in a negative exponent. I'm going to put a -2 on the outside. So I think your guys has nothing. Let's throw in a negative exponent. All right, so these that look super complicated, what can we try to do first to maybe make it a little simpler? Yeah, you thought that too? Okay, nice. So we can simplify the inside. All right. Do our coefficients simplify? 3 and 4. No, so we can just leave them alone. This is just going to be 3 over 4. Does x, are there any more x's? The x right on top and the x on the bottom, what does that give you? Just an x on the top, nice. What about a y to the -1 and a y to the 3? Okay, good, so we get... Okay, so when you do, there's a couple ways that you could do it. You could either move the -1 to the bottom, or you can subtract the exponents and you're going to leave it as that, right? Y to the -4. Let's just say we did that, right? That's perfectly fine. And then what about the z's? Okay, so then, yeah, so we can kind of do something similar. You have options here. You could either apply your rule of subtracting, or you can move this to the top. And then when you do that, you get you should get z to the +6 no matter what. And this is all to the -2. Okay, good. You could move this y to the bottom. So why don't we do that? Again, your steps might look a little bit different from mine. That's perfectly fine. And then we get to the -2. What are you guys thinking now? What can we try? Sure, let's do it. Why not? Let's distribute this negative exponent to everything. So I'm going to move that here, here. And then what does that give us? 3 to the -2, x to the -2, z to the 6 to the -2. That's it for the top, and then on the bottom we get 4 to the -2, and then we get y to the 4th to the -2. All right, I didn't do anything more in that step other than distribute the negative exponent. Are you okay with that step? Okay. What can we do now? Okay, so you can move your negative exponents. Nothing wrong with that. So everything that has a negative exponent on top can go to the bottom. And then that can move to the bottom, that can move to the top. So then we end up with 4 to the positive 2. A y to the 4th to the negative 2. Or I'm sorry, positive 2. Over the 3 to the negative 2 is going to move to the bottom and be 3 to the positive 2. We get x to the positive 2. And then we get z to the 6 to the positive 2. So doing that just made all of our negative exponents positive. There's just one more step, guys.
Actually, like square it.
Yeah, right. You actually have to square everything, right? So the top is going to become what?
Times y.
Good.
And then the bottom is going to be 9 times x to the second and z to the 12th.
Nice, right? Power to a power you multiply, and then the numbers you can just simply evaluate. There's nothing more you can do there. I don't see any more negative exponents. So this is fully simplified. What can we try here? Okay, good. So we can just distribute the exponent. Whoa, sorry. We can just distribute the exponent on the left term. So that 2 is going to go to each of these. And then on the right side of the plus, there's no exponents on the outside, so I think we can just simply multiply it. All right, you guys agree? Good. So then this is going to get you 3 to the second power, x squared to the second power, y to the 4th to the second power. And this is going to be plus. When you do 2 times a negative, that's going to get you a negative 2. X times x to the 3rd, what does that get you? X to the 4th. And when you do y to the 2nd times y to the 6th, what does that get you? Good. So far, so good. And it looks like the left-hand side we can simplify a little bit more. Once you do your power 2 powers and your squares, what do you get on the left side?
9x.
Very good, guys. And then plus a negative just becomes minus, so we get minus 2x to the 4th, y to the 8th. Are these like terms? Can I combine these?
Yeah.
Yes, we can. So we just combine the 9 and the 2. So we get 7x to the 4th, y to the 8th. Not so bad, right? Good. Nice, guys. Okay, good. So if you weren't here, you watched the video maybe, but you still need me to explain it. I'm going to show you. You can, with radicals, I prefer to just extract the perfect squares, right? So we know that 63 is the same as 9 times 7. So I know that this is the square root of 9 times 7. And then this right here is a perfect square, so that's going to become 3. Square root of 7 is not a perfect square, so I'm just going to leave it alone. This 4 in front is being multiplied, so I'm going to do 4 times 3 times the square root of 7. You can only do the whole number times the whole number, so this is just going to be 12 square root of 7. 7, there's nothing more that you can do to break it down. It's just 7, so this would be our final answer. If you like the factor tree, you could do 63 and then do 9 and 7, and then 3 and 3. And then you see that the 3 shows up twice. So that's going to show up once outside the radical, right? 1, 2. So then it's going to show up once out here.
I did like a mix of both.
That's fine. Questions on that one? I think we're okay there. Okay, something like 13 should be pretty simple, but some people mess it up. So what are we thinking here?
You have to throw 1 over the.
Yeah, good. Well, first, what's our base here? Is it negative 144 or is it just 144?
144.
Okay, good. So it's just this 144. Wait, hang on. Okay, yeah, so it's just this 144. That means when I write this over 1, what's moving to the bottom?
The 144 and the exponent.
just the 144 and the exponent. So the negative is going to stay on top. So it's going to be negative 1 over 144 to the 3/2. All right. Can we simplify that a little more? Okay, good. This 2 can go up front. This is going to be 1 over the square root of 144, and then this 3 on top is the exponent. What's the square root of 144? Good. So then we should get negative 1 over 12 to the 3rd power. It's going to be a big number, but
1,728.
cool. And so we should get that as our final answer. All right. We did something like this in your warm-up. How do we simplify something that looks like this? Okay, so you make the bottom one, right? Make the bottom one negative. It's 4 minus the square root of 3. We do that on the top and on the bottom. What's our shortcut for the bottom? What do we do there?
16 minus 3.
Okay, good. So you can square the first, so 16 minus, square the second, so 16 minus 3. And the top we can just FOIL as normal, right? So we can do 4 times 4, 16. 4 times negative square root of 3 is minus 4 square root of 3. Inner times the inner is going to be minus 4 square root of 3. And then last times the last is going to be plus 3. Negative times negative, and then square root of 3 and square root of 3. Do we have like terms on top? Yeah, right? So we can combine. 16 plus 3 is going to get you 19. And then this radical and that radical, bless you, is going to get you negative 8 square root of 3. Again, you can treat the radical like a variable and just combine the numbers in front. And then on the bottom, you can simply leave it as 13. Nothing more we can do there. We got the radical out of the bottom. Everything on top is fully simplified, so you can leave it alone. Sorry. Good there.